Okay, good evening. Welcome to
Math number 50.
Math number 50. So we're going to revisit Patrick Connor's problem and talk about two alternate solutions that I heard about today.
Alright.
So one was called turtle geometry. So did you bring a turtle?
No.
Okay, so we're going to have somebody walking down the path here. And we're going to see just from how much they have to turn if we can figure out what those angles are. Okay?
So he starts like this.
Starts walking down the path at what angle?
45-degree angle.
Okay. And then how much does he have to turn by there?
Well, 85 degrees. Or do you have to turn this way?
That's an interesting question, actually.
Because, I mean, he could turn a small angle. Or the big angle.
Yeah, which one? When he turns that way, which way is he turning? So we're going to assume he's facing this direction when he walks down. Okay.
So, how could you tell if he's turning either 85 degrees clockwise or 275 degrees counterclockwise?
Yeah, good question. How could you tell?
But, like, is he always going to have to turn one direction?
I don't know. We're look out on the path. We're just going to try to learn what happens.
This doesn't make any sense.
Why not?
Because it doesn't matter if he turns this way or that way. Is he still going to make it in the same direction?
Interesting. Okay. So why don't you put the whole body on in person, and we'll have him slide down the path, lying down.
So that.
Okay.
And then that.
All right. How much did he turn by?
So he turned by. Well, he would turn by actually the supplement of 85.
Okay.
Which is 95. Because it adds up. He's facing this way, then it turns and adds him up to 180. Because he's on a straight line here.
Mm-hmm.
So this angle here is the supplement of 85.
Okay.
And that's how much he turns.
All right.
95.
Cool. All right. So he turns 95. All right.
And then he goes on here.
Why don't I write down? So the first turn was 45, and then you're saying 95. Okay. And what does he turn? What does he turn here?
Well, he turns 180 minus theta.
180 minus theta. Okay.
And then he moves down to here, then turns 30 degrees.
All right. Okay. Now I just wrote down 45 degrees in the beginning. So let's make sure that we've got that.
Yeah.
Right. So
he turns 45.
Turns 45.
Then walks down here and swings around 95.
Okay.
And swings around to 180 minus theta.
Uh-huh.
And then swings up for 30.
Okay. And what should happen when we investigate all of these turns?
Well, they should get us to 180 or no, they should get us to 360.
All right. You think he turned all the way around?
Well, yeah, because if he turned 180, he'd be facing this way.
That's right. If he turned 180, he'd be facing this way.
Cause,
But did you see him make a complete revolution when you turned?
oh, Well, it's not really, it doesn't look like a complete revolution.
Okay.
So.
What do you think's going on?
So how much would he turn by? Because you start on the same line, or
Okay.
the same angle.
Yeah.
So, goes 45, then turns 95, then turns back this way,
Okay.
and back that way again.
Oh.
So I think he turned 0.
Okay, so it looks like he turned 0.
Because he's turning two times in one direction and 2 times in another direction.
Ah, can you circle the angles that went in the same direction?
So this angle and that angle,
Okay.
and then
And
that
that
angle,
And that angle went in the opposite directions. Okay, and so what should those add up to?
I should add up to 0.
Okay, so which angles are positive turns and which angles are negative turns?
These are positive, these are negative.
Okay, awesome.
So you have 140 minus 180 plus theta minus 30 equals 0.
Okay.
So you've minus 40 minus 30 plus theta is 0. So theta is 70.
Is that the same answer we got this morning?
Yeah, I think so.
Yeah. So that's actually really interesting. So you're just paying attention to the changes, and it's tricky to pay attention to the positive and negatives. But you did a good job figuring this out. Positive 45, positive 95, negative 180 minus theta. That's a tricky one. And then negative 30, I think. So this way is called turtle geometry. Why do you think it has that name?
Because you're like crawling along that line
Like what?
like a turtle.
I wonder why they didn't call it worm geometry. Anyway, that's really neat. That's really neat. I feel good work. Good work, hon.